Okay, so now we're going to talk about the last part of a simplex method problem, which is interpreting the final tableau, right? So again, that comes after stating the problem as a standard maximization problem. Part 2 was making the system of equations into inequalities, the constraints into a system of equations, and adding the objective function in there. Part 3 was setting up the initial tableau. You've seen part 4 where we talked about pivoting, the process of how you get an initial tableau into the final tableau. So now let's suppose that we've done that. You've seen that video. You've seen this last frame. Okay, here's what the final tableau looked like. It took a couple of pages of work. This is a non-trivial problem. This one that I made up to motivate the idea of packing a cargo plane. So let's see what the results are. Okay, so the final tableau looked like this. Let's see. As you would want in a final tableau, it has several columns with just zeros and ones in them. That was our column to do with X. Column to do with Y looked like 1, 0, 0, 0. The column to do with P had 0, 1, 0, 0. And then we had for S1, S2, and S3, these very busy looking columns. Let's see, I had 0.104 in here, approximately a negative 0.007 in here. We had 1 0 there, a 0.253, what's it called, 4 there. It's going to turn out that those numbers don't matter so much, as you're going to see why in a second. Negative 0.005 in the S2 column, 0.001 in here, a 0, a 0.308 here. In S3 we had a negative 0.42 about, a negative 0.02 here, approximately a 1 here, a 2.56. So this should look familiar from the last frame of the pivoting video. And then under Z, we had 0, 0, 0, and a 1. So that Z column didn't really change, which is why some people, when they introduce this method, they kind of leave the Z column out altogether. But for interpreting purposes, it's good to remember that it's actually there. So that's why I still have it. And in this class, I think you should include it so that you are reminded at this key juncture about to come up what's really going on. All right, so in the final tableau, we had numbers like this: 2147.67, 151.62, 800.0, and 72,217.48. And that was after a lot of messy row operations. Again, if a computer does that for you, if you ship it, give it an initial tableau, or give it some objective, a maximization problem, depends on the software, it goes through and does a lot of operations to make it look like this. Your job is to interpret that. All right, so we're going to take advantage of the fact that we have a bunch of nice clean zeros and ones here. That doesn't always happen in the first 3 variables, okay? But to be able to ignore what's happening in these messy columns, we're going to do the following things. We're going to say that these are not fundamental to our solution. We're going to say that every time you see a bunch of numbers in here that aren't just clean with 1, 1, and a bunch of zeros otherwise, we're going to call these, in this case, it turned out to be these 3 right here, the non-basic variables. basic as in fundamental to the solution. And turns out in this problem, it's rare actually, that the basic variables are lined up in the 3 columns. Don't just take the first 3 columns. These will be our basic variables because they have that nice basis look. Just 1, 1, and everything else is 0 in each column. Okay, for the non-basic variables, we're going to set these equal to 0. So we're going to say, you know what? Let's take S1 equal to 0, S2 equal to 0, S3 equal to 0, because those happen to be our non-basic variables. Then when we go to interpret this system of equations, this tableau back as a system of equations, we don't have to worry about these coefficients, because if you set S1 equal to 0, then the coefficient 0.104 times 0 is just going to be 0, right? So I'm going to get rid of my initial tableau so I have some space here to do this interpreting. Okay, we start by saying set the non-basic variables equal to 0. Okay, what else do we know? Well, look at this last equation here. I'm looking at this one just because in my first column, that's where the 1 is. Okay, that last equation, look what it's saying. It's saying 1x plus 0y, 0p, 0s1, 0s2, and 1s3 is equal to 800. Okay, that's my third equations in third line interpretation. Third equation becomes this. Well, but that's the same thing as saying, since S3 is equal to 0, then we've got x plus 1 times 0 is equal to 800. In other words, we now know what x is. X is equal to 800. What was x? X was, if you remember, back in the beginning, the number of large water containers. So this is saying the ideal way to pack this plane is to put exactly 800 water bottles in there. That just came from that first row being representing the basic variable for x. What's happening here for y? We have a 1 up here. So that's the operative equation. That first equation, first line, gives us a first equation that now looks like 0x plus 1y plus 0p plus some number of s1s, but I've set them equal to 0, plus some number of s2s, but I've set s2 equal to 0, can ignore, equals 2147.67. Well, that just means that y is, and this is approximation. By this point, after all the pivoting, you know that this is approximation. Y is approximately 2147.67. Now to interpret, what did y stand for? Back over here, y was the number of medical kits. Can you have 0.67 of medical kit? Not if you're packing a plane in a hurry. You're just doing whole containers, right? So that means we're going to take y equal to, and you don't want to round that up because that might go over the constraints. So you just would take that to 2147. That's as big as you can get it and stay within the constraints. It's an important thing about rounding. What else we got? In the p column, we've got 1p. So in that second equation, it's becoming this. You should stop the video and do it yourself. See what you get, come back, see if you agree with this. We're getting that 1p equals, this doesn't matter because I've set all those equal to 0, so their coefficients don't matter, 151.62. Again, immediately start thinking about what that means. What did p represent? P was the number of pallets of food. Sorry about the plumbing noise. P is the number of pallets of food. Can you have 0.62 of a pallet of food? No, but you can have P is approximately, so again, don't round up, round down, 151, okay, pallets of food. So this was containers of water. This was medical kits. This is pallets of MREs. Okay, and look at the bottom line. Here's the punchline. The bottom line says 0x, 0y, 0 p's, plus some 0.254 of S1. Hey, but S1 is equal to 0, so we can ignore the S2. It's been set equal to 0. We can ignore the coefficient of S3 because S3 has been set equal to 0. 1z. So this is our fourth equation. This is the punchline. How many lives, the optimal amount of lives we can save within those constraints, okay? 1z, z represents the total number of lives saved for 3 days, right? By the arrival of all these goods. 1z is equal to this, 72,217.48. Again, you can't have fractional number of lives. So you would just say maximum number of lives potentially saved by all these goods, right? They have to get them off the plane and distributed to the people. Does that really happen? Anyway, potentially the maximum number of lives saved by a cargo plane, C5, full of goods for 3 days is 72,217. Again, don't round up, just take the integer part. Okay. And so that's how you would write your solution. That's how you interpret the final tableau. Okay. Just for note, on tests, one test question might be, can you set up the maximization problem from an English word problem? Separate test question might be form the system of equations introducing slack variables. Part 2. Part 3, set up the initial tableau. That might be a separate test question. Part 4, pivoting, as you saw in the pivoting video, takes a long time. Might just ask you to do one of those pivots instead of all 3, right? But you should be able to do any of them and know when you're done. And 4, interpreting that final tableau. That could be another test question. You could just be given a final tableau and the initial word problem, interpret the results. Okay? All right.